With the cursor keys, we move the tool to the setup length, acknowledge with Enter, enter the correct length, and the question appears. We now acknowledge the 100 millimeters, and setting up is thus completed. We again acknowledge the menu point, Automatic, with Enter, and the machine immediately starts to automatically execute the program. For the computer has naturally noticed the position of the tool at the start. We can remove quite substantial chips with this machine and follow the tool on the screen right to its end position.
Can we also machine more difficult contours?
Yes, of course.
And everyone rushes to start the next job.
We will not show the designing in such great detail this time. We'll machine this contour, for example. Setting the visible edges, mirroring, everything we've already heard merely needs to be repeated for each drawing.
The program is written quite easily, regardless of what sort of contours the workpiece has. Our Unimat PC manages simply everything.
In order to demonstrate how the workpiece is machined in layers, there is point 9 in the menu display. That is simulation. Here we see how the workpiece is actually machined by the machine.
Material is removed layer by layer, and quite a lot of big chips are removed. Even Paul, the skilled worker, is amazed at the precision of this small automatic machine. Willie now explains the principle of computer-aided machining.
The computer always keeps an eye on the contour and orientates itself on the contour point which it can recognize. Starting point, next point. That would be the next one. And this continues right to the end. The blue line represents the work process roughing. These parts, which are still unfinished, are machined with the program step, back pocket. We now have a new contour and therefore acknowledge it with any key. This is now our new starting point. We define the contour in the same way as in the program point roughing. Look for the starting point. Aha, in the other direction with the number key 1. That's it. We acknowledge with Enter. Again Enter. And again, and here we have to make another jump. That is our last point with the number key 3. After we have entered the feed again, machining commences. As the PC cannot look behind a contour, this second part, to be relieved, has to be defined in the same way. Starting point, other direction, and acknowledge. Yes, that's enough. We finish with the number key 3 and execute the program again. All the data which the PC has asked us are already stored, of course, which means that we only have to acknowledge, and the last part to be relieved is now machined in the same way. Don't forget, after the last defined point, we would have to again acknowledge with Enter. We have now machined all 3 parts to be relieved. The entire program has now been completed. We can observe in the simulation how the machine and the computer actually function. Firstly, normal roughing, then the relieving work.
In the main menu, Drawing, we find the submenu Cursor, and under it, various functions with the cursor. We proceed from the reference point with the absolute dimensions. We now enter the desired dimensions, acknowledge with the Enter key, then the plus key. With F2, we return to the point Cursor Absolute, and the question again appears. The dimension for the x-axis remains the same, and the dimension for the z direction with -10 is added. We acknowledge again with Enter, and then the plus key. With these two data, we draw a diagonal straight line. Our programming operation for drawing simply repeats itself. Every input number which is not changed in the next step remains the same. Our endpoint is now located 20 millimeters away from the reference line. And 15 millimeters from this line, both of which are defined in relation to the reference point. The incremental dimension takes the last dimension point as the starting point for the other dimensions. The question is now x and z motion from the cursor.
The procedure is the same as the previous one. The dimensions are, however, entered from the last cursor point, which is also our last dimension point. Don't forget, after every dimension, press Enter and the plus key. Only in this way can you acknowledge and draw. This point is now related to the last dimension point.
Another important point in the cursor menu is the point Step. In this program point, I can change the cursor step with the number keys as I want. You acknowledge again with the Enter key, and the entered cursor step appears in the menu list. A simplified change of the cursor steps can be achieved with the page up, page down keys. The cursor step is halved or doubled each time these keys are activated.
One of the most important chapters is the arc menu. We draw an arc using the cursor. Mark the starting point with S, the center with M, and the end point with E. We note that a point of a circle is always drawn in counterclockwise direction, as is demonstrated here. Regardless of what position the arc is located in, we draw an arc with these 3 points.
In order to be able to accurately define the character geometry, we sometimes also have to look for an arc. With F2, our cursor then jumps to the next arc. The division of the arc is quite important for writing a program. With the cursor, we move to the pitch point we want and enter F3. The arc now has its pitch point there. As it is divided, we acknowledge with this key 2 times and the arc is deleted. Drawing a full circle is quite easy.
In order to draw any arc of a circle, we set a starting point and an end point, and then with the cursor, move to the position which is to touch the arc as the 3rd point. Acknowledge with F6, arc through the 3 points. And our PC has already drawn this arc just the way we wanted it.
Arc menu, point 8, curve 2 elements, for example, of a straight line with a circle. First of all, we set the curve at the straight line. Enter, define, then the element number 1, that is the straight line, by moving the cursor to the line and pressing enter. The next question appears. We now want to place the curve at the circle. Enter the curve enveloping the circle with the number 1. Enter, and we define the element number 2, and again press enter. We specify the radius as 15 millimeters, press enter, and move the cursor to the approximate position of the center point. Is this the side we want? In our case, yes. We acknowledge with the enter key, and we have now drawn this curve. Should the PC draw a different curve first, we simply acknowledge with the space bar, and the question is asked a second time until the correct curve appears on the screen, and we can then acknowledge with enter.
The rounding of corners is also important. We move the cursor near the desired corner and press F7. The question is then, we enter 3 millimeters and press enter. Our screen asks everything else, and we merely need to acknowledge with enter or negate with any key. Careful, the rounding is not actually drawn until after the entry acknowledgement. We proceed in a similar way in the menu Straight Line with the Command key 9, chamfer.
A very important selection in the submenu point is the command F8, clean corners. We move the cursor near the corner to be cleaned and acknowledge with F8, clean corner, in reply to the question. We proceed with enter, or with any other key except escape or enter. Okay, I understand all that, but what does that mean under the menu point, Machining Program Scale F8?
This is really a great idea for model builders. We have a factor for increasing or decreasing the program. If, for example, we enter 0.5, then the entire program is halved. With the number 2, we double the scale again. Any scale desired is feasible.
And shifting the program?
Yes, you can do that in any axis direction. You can shift your program, for example in diameter, by 2 millimeters, and the diameter becomes 2 millimeters smaller or larger.
That's really a great idea.
Yes, and there's something else called hotkeys. With them you can draw, design, and work even faster, but you'll have to look up details for yourself in the software description.
And you can even print things?
You can do a lot more, but obviously we can't show you everything in such a short time. We only want to demonstrate how easy it is to work with the Unimat PC.
Education and vocational training for everyone. For the model builder, the skilled worker, the PC user, and the school child.